Okay, good afternoon. This is Dan from the House of Broken Dobbs Things, and today I'd like to do a review and a shout out for Jim at Tangent Engineering. I had a discussion with him the other day on the phone, and he is quite a character, and I really enjoyed it because I'm old school, he's old school, and I had a great conversation. I was looking to purchase one of these, and apparently he's had such a demand on them that they're in production now, and they'll be filling orders shortly. But he says, "Hey, you've got a channel." Yeah, small channel, nothing big. He's like, "Well, how about I send you one free of charge?" I'm like, "Oh no, Jim, that's okay. I have viewers, reliable viewers, but I'm not going to be one that's going to get you a lot of exposure." He says, "I don't care about that." He says, "I just want to get it to the right people to give it good word of mouth so we can make a good run of it." So here it is. I offered to pay for it. No, he wouldn't have it. So once you talk to Jim, he's a force of nature. You'll be brought along for the ride. I really enjoyed it. So what we have here is the 5-inch Lathe Compound Sine Bar. Very, very nicely packaged. Just I don't do unboxing videos, but just to give you the idea there. And then Jim's information is in the box. Never mind these. These are my own personal little project. There we go. Yeah, it's better. This is the sine bar itself. It goes on your lathe compound. There are 2 pins right here. This one is 5-inch. So these are exactly 5-inch on center. These are the backside of some rare earth magnets. It's got a lot of power for that. And then I'll just flip it over and give you the bottom side view here. So there's your rare earth magnets right there, and then there's the hardened pins. This is stress relieved. I think it's 1104. Anyway, you just have to see it, look at it, then you touch it. It's like, oh my gosh, this is really, really nice. Not something you're used to getting in today's age, where people are trying to blow stuff out fast as they can. This is really high quality. The edges are cut. It's just gorgeous. I mean, it's like, wow. So from that, there's also some amenities that he added. Obviously, the pins are there at the exact element there, and the rare earth magnets are going to hold to the compound. We'll show you that more later. But he also added in these 1032 screw holes here. And then he calls them jack screws, which allow you to, and I'm going to show you an exact example of what they're there for, relative to coming from this side, and the jack screw will let you come down, and I have to try it, but I'm pretty sure that the earth magnets won't mind a little bit of offset to go around an obstacle, for instance. Okay, so there's just 2 of the jack screws right there, but let's say, and I actually have that exact problem on my lathe, so we will overcome it, and these will allow us. So there are 4, so you can dial these in, and actually the rare earth magnets are going to be pretty snappy from a pretty good distance, so you're going to get that hold down. Your points are going to be out here, but it's actually going to be holding on the magnets right here, holding it snug. So these jack screws are there to help you overcome slight obstacles, whether it's a curvature or anything else that's on your compound itself. I know he's done several really good videos where he's using Bobcat on screen to show you exactly what's going on with and he's done several different variants so far. The South Bends, there's some issues with them as far as the casting curvature and things like that. Mine is actually flat, and I'll show you, but there is one obstacle that we need to overcome, and these are already pre-positioned very smartly to allow you to overcome that. So very high quality unit packed in very, very dense foam. This package will last you a long time. These screws here were just some that I 3D printed at. This thread pitch right here is a 1032. Okay, before we get too far with the sine bar, I just want to give you an example. This is a Harrison M250, also known as a Colossing 11. Those of you who watch my channel, you're familiar with it. Its big brother is the M300. John's workshop in UK has one of those, and actually he's in Scotland. So from that standpoint, in this one we have an oil get, if you will, right in the middle of the way. So what it is, and kind of show you why Jim's already thought about this, is I can't lay flat with this big humposaurus right in the middle of all of it. Okay, to give you an example, we can line this up, if you will. I'm just going to angle that just for the sake of clarity. I have enough room there. I don't need to even pull the tool post off. But so if you notice, it just can't get there from here because that git is right in the middle of the way. So with those jack screws, we can go ahead and take a quick reading on this thing. And again, you notice it's raised. It's raised on purpose. I'll show you in a minute. Okay, let's just get a rough cut where it is. It's about 150. It's 148 and a half. 148 and a half. Let me lock that. All right, I'm going to set that to an extra 10 thousandths. Let's go 158. Let's go 16. That's close enough. And I'll take this. Those magnets are good, Jim. Set the jack screw right about the right. I should be pretty close to clearing it now. This is one way. So coming on right here. Okay, I've got good contact here. I have good contact there. My tool post is clear, so it is flush, and it is, with one exception. Okay, it is there. Okay, it is in place. Now I would take an indicator and sweep that. That would be fine. But that's just one example of how you can get around one of those issues. And they're plastic, so they're not interfering with magnetism or anything like that. In other words, this is not pulling down. These plastics are really doing nothing. It's only the magnets doing what they do. Okay, so that's one example. Okay, that's how you would get around it. And thanks, Jim, for thinking about us to get around that stuff, so you didn't have to make 75 variants. You could just provide an option for it. Within that one, this git really isn't all that crucial. It's only for the compound screw, which outside of cutting tapers really is the cycle on that is going to be very limited. So it doesn't really matter. However, I was searching and I found a different kind. The difference between these two is mine has an edge, this one does not. So it's same function, same diameter, but it should go down below the surface. So that will just negate all that other jacking around, if you will. So from that one, I just got that set in position. I'm just going to go ahead and drop that in, but that should go below flush, and it should be no more of an issue. Just before I got on here, you may see it looks a little rusty. It's actually very, very smooth. It's just surface rust. It's below, right into the grinding of it. Looks worse than it actually is. And I stoned this off before I got started on the top and the bottom, so that should be okay. But this ugly wart, it was great. It was fun, but sometimes, you got to break up. I'll bring it right back. Just making sure I don't have any really kind of raised surface to any amount, and certainly that I didn't go into the compound screw and get into the threads. Yeah, I don't think that's going to cause any heartache for anybody right there. I'm going to get a punch and take that down just a little bit more. That's a knocker I use on the mill. Nice big hunk of brass that it just came to me out of the scrapyard dirt. All right, I'm going to just barely touch that under the surface. I'll be right back. Okay, no issue with the compound below the surface. not snagging on anything. I think we should be in great shape now. Okay, I do love it when a problem comes with a $7 solution, and that's $7 for a bag of 10. So I don't have any other issues with any of the other ones on here, but for that one, it's like, let's just give it a simple solution. So I think it's going to work out just fine. I use a chainsaw oiler with oil. Yeah, it drips out, but basically it does the job. Okay, so that'll be just fine. Okay, back to this. Now we can get rid of the jack screws. Don't need them, but they're there. Should we run into? I have 5 or 6 different lathes running around here. You've seen some of them in previous episodes. I think it's 3 South Bends now, an Atlas. This Hardinge, not a Hardinge. This Harrison, and then a old Sydney I've showed in a previous episode, 100 years old. So, with that all being said, oh yeah, Jim, right there, buddy. Watch out for your fingers, folks. Those magnets are not puny in any way, shape, or form. Okay. Again, I have clearance on the tool post. Let's see here. Oh, I'm hitting right there. I need to... No, actually, I'm going to need to tap that tool post first. There it is. It fits magnificently. You can see the pan alignment on there. Looks great. Dan, did you add more lights? You bet I did. I was sick to death of putting you all through the dark corner that this lathe is in. It's in between garage doors, so there's nothing I could really hang, so I had to rig up something with an additional LED, and then I have an extra light going on and an additional backlight I just added. So there it is. Fits great. There's no wobble at all. It's good to go. So we have to make some adjustments on this one. I was going to try to play around with a Morse Taper 3. So that's what I have in my tailstock. And the tailstock on this one is not prestigious or premier. This lathe was initially sent into a technical school, and there are a few things on it they absolutely beat the thunder out of. But most of it is fine. I mean, absolutely fine. So one of the things they beat up was, of course, the tailstock quill, spin outs and things like that. You've seen that in an episode of mine where the drill chuck spun out. Well, I've worked on that, and I think it's going to be not showing up anymore. When I was doing copper or brass, it was actually pulling the Morse Taper 3 out of the quill and starting the spinning, and how humiliating that is. So let's get started here. I added this style nut here and got rid of the little nuts. These make it pretty convenient to loosen, just like that. So now we can play around with that, and makes it a little easier. I don't need a wrench. And then we're going to get set up and start dialing this thing in. Okay. Again, I moved the tool post just quickly because it is not part of this problem at this juncture. So once we get the compound set, we're going to be all set. So just actually going to probably start this off somewhere close to parallel. Here we go. And I'm going to get the indicator set up, and we're going to try to set the gauge. Again, the number on that one was a 0.12544. That's just a whisker over 1/8 of an inch. I'll see what I've got in the gauge blocks to see if we can make that. But actually, I may run off and then grab some rolling papers or something like that. Not that I have a need for them, but they may come handy in the shop. Okay, bring you right back. Okay, my combination is 125 and 0.12544. And this is as close as I'm going to get. Nice gauge, like a 121. And then this particular kind, I've been searching around the house for about a half hour trying to find something that stacked up nicely. So this particular manila envelope seems to work well, and the combination works well. So that's what I'm going to go with. Go with what you got, right? So let me get the indicator set up, and we will start dialing this thing in. let's start bumping and thumping and getting this thing lined in. Okay, I've got the compound turned, or not the compound, the cross slide turned in, and then we are going to move the carriage. And again, it's way off. Okay, haven't even started really doing much of anything. Okay, and from that one, this end is proud, so we need to skinny off a little bit of that. And adjust this to 0 again. And see about where we are. Okay, way better. Way better. Okay. And my previous mistake was to try to adjust it at each end, and it's like, especially on the middle, you kind of like going back and forth, back and forth, back and forth. So I'm going to, alright, and we're going to 0. And then we are going to sweep it again. Much better. Oh, that's great. Okay. We got it within pretty good where it's going to be. About 20 thousandths over where we should be. Just going to pull over for a second. See how things look. I love having a DRO. Surface finish is garbage. Oh my God. It is garbage. Jeez, something's loose. Well, it's not the compound or the cross slide. Yep, I need to cinch down on that compound. It's doing garbage work. Alright, everybody. Surface finish. I mean, that had to be from me cranking the compound, but this is Morse Taper 3. Checks. I just overcut it. Dadgummit, I just had it. Yep. Sure did. That's that couple of thousandths you don't want. Dagnabbit. Blew it. Oh well. I did have it up there a while ago. It was gripping, and I did that quick little polishing thing. So, yeah. Just blew it. So, great tool. I need some work on my machine, but it did exactly what it was supposed to do. Everything that was a shortcoming was on my side, but the Morse taper setup for the sine bar was simple. It was easy, and even I could understand it, but boy, did I blow that. Yikes. So, okay, I'll bring you back. Well, there you go. I went ahead and got mad. Oh, not mad, just like, okay, what the heck. And went ahead and pushed on past my initial boundary down here, and then picked up the taper again, because what I did is I basically ran up against the edge. Not the taper was still there, it was fine, but I went ahead and grabbed it and then took off with it, and it picked up the taper, which the tool set perfectly, and then here we are. So let me do that one more time because my camera didn't turn on a second ago. Wow. She grabbed it. Okay. I didn't polish anything. I was mad and I just let it run, but this is the Morse Taper 3 adapter. It is hardened and ground, and I went ahead and pushed. Here's where I originally stopped, and then I pushed on through here using the same settings that I had right here. So in other words, I blew the curve by probably a few thousandths, pushed it down, and then the taper picked up again. You know, it used to end right here, now it's ending right here, and it picks up and goes just fine. You'll see that even without me cleaning up the surface finish, it's right there, but there it is. That's it spinning the chuck. So that's a win for Jim, a fail for Dan, but that's okay. I learned a lot. And then basically that's it for another episode of the House of Brook and Dobbs Things. We cut a Morse Taper 3 and blew it, but the tool worked perfect. So thanks, Jim. I appreciate the gift. There's your evaluation. I don't see anything that it could have done better. And it was simple, fast. I was able to do it and never done it in my life. So within a very few minutes, especially with your new chart that you've made up, that made it even super simple for me. I just want to go back and say, that was genius, Jim. Thank you. That cut to the chase. Otherwise, you'd be looking around in the Machinist Handbook and a few other places that, you know what, it's all in one spot. For those of you, I'm going to post Jim's tool address and everything else. You can send him an email and get in line to order it because they're going to go fast. As soon as people use this once or twice, they're going to have it. So thanks again. That's Dan from the House of Broken Dobbs Things. Have a great evening and have a good next week.